In this video, we're going to use the first derivative test to find local extrema of an algebraic function. It says use the first derivative test to find the location of all local extrema for the function given below. Enter an exact answer. So they give us f of x equals 4x cubed divided by 3 minus 7x plus 6. First thing I'm going to do is take the derivative. So f prime of x would equal, bring the 3 to the front, I'd have 3 times 4/3, and then I'd have x squared, subtract 1 from the exponent, minus derivative of 7x would be 7. Let's simplify that a little bit, and we end up with 4x squared minus 7. Now I'm going to set that equal to 0 because I want to find where the slopes become 0, because that's where we're going to be like either peaking out or bottoming out. So we'll have either a peak or a trough there. Let's solve this. Add 7 to each side. 7 equals 4x squared. Divide by 4. We get 7 over 4 is equal to x squared. Square root each side. So I got plus minus root 7 over 4 is equal to x. Let's simplify that a little bit, and let's write that as plus minus root 7 over 2 when I take the square root of 4. So I'm going to draw a number line now. And I'm going to mark negative root 7 over 2 and positive root 7 over 2. And then I'm going to test them. So this is the first derivative test. So I find the first derivative. I've set it equal to 0. These are the critical points. And then I graph the critical points on a number line, and I do the first derivative test where I test different intervals and see what the signs are for the first derivative in those intervals. So root 7 over 2, I'm just going to pick 5. That'll work. We'll pick negative 5 here. And so I'm testing these into f prime. So I'm saying f prime of negative 5 is equal to, and then I'm plugging them into this function. So I get 4 times negative 5 squared minus 7. I'm going to do f prime of 0. So 4 times 0 squared minus 7. And then f prime of 5. 4 times 5 squared minus 7. So this will give you 25 times 4 is 100 minus 7, that's 93. But we don't really care what the number is. We just care that that area is positive. Positive slope there. And then we do this. This would be 0 minus 7. That's negative 7. Negative slope in here. And then this will be 93 as well. So positive slope here. So anytime I go from positive to negative slope, I have a max. Anytime I go from negative to positive, I have a min. So I have a local max at x equals negative root 7 over 2, and a local min at x equals root 7 over 2.